Okay, so I'm going to talk about section 13.4. We are not going to be tested on this section, but I just want to make this brief video because there's this really cool thing that we can do. So this section is about finding the volumes of irregularly shaped objects. We now know how to find volumes of very nice looking objects, but what if the objects don't look so nice? So this is something we actually did with areas. When we had the area of irregular objects, I think this was 12.8 or 12.7. What we did is we put the objects on a grid, and we did different types of things. We counted and saw how many squares were like inside the object, and we computed the area and went from there to find the approximate area of the shape. We also did over and under estimates. Technically, the same idea works for three-dimensional objects, but there's an even cooler way to do it. So I've got a milk carton full of water, and I've marked right there. You should see a blue marking right here. There's actually a couple things showing up, but it's this lower one right there is where the water level is. And what I want to do is use this to find the volume of this lime. So these might seem unrelated, but trust me, it'll work. So the reason that this lime is harder to find the volume for is that it's not exactly a sphere, it's a little ovular. There's also this little dimple right here. So how do we find its volume? So here's what I'm going to do. I'm going to drop it into the water and watch what happens to the water. Sorry, my roommate's coming in to get water. Watch what happens to the water level when I drop the lime into this carton. So you should have noticed the water level went up. In particular, that blue mark is now below the water level. So if I take the lime out, you should have seen it drop again. And now it comes back up. Okay, how does that help us at all? Well, that small difference in height from the bottom of the line to where the line is now, all that water that's in between those 2 points, the water that's now above, got displaced when I put the lime into the water. That means all of this water that's now above was taking up the same space that the lime is, which means the volume of the lime is equivalent to the volume of this water. And we can find that because this container is a rectangular prism. So we can measure the dimensions, and I'm just going to be very rough about these dimensions. So the base is a square, and it's a 4 by 4 square. So area of the base is 4 times 4. And now I need to account for the height. And the height is just going to be the height of the water level above the mark. So I'm going to put my marker below the water and see where the water level stops. And it stops at right about, let's see, at that mark. And what is that mark? That mark is 1/3 of an inch. Okay, so the rectangular prism I have is the base of this square, and the height is the height of the water from the bottom of the mark to the top of the mark, because that's the water where the lime was. And if I do this computation, I get 16/3 cubic inches. And that tells us that the volume of this lime is exactly that number.